Imagine a place where the stars stop twinkling and galaxies decide to call it quits. What secrets could be lurking beyond this newfound boundary? Are we on the brink of unraveling the greatest cosmic mystery, or is this just the beginning of a whole new chapter in our cosmic adventure? Well, it seems it is. Webb claims to have found the end of space itself. Yes, you heard it right. The final frontier might not be so infinite after all. But hold on a sec. How can space have an end? Wasn't it supposed to go on forever? Okay, let's see what's really happening. When I heard this news for the first time, I was all pumped up to uncover one of the many mysteries of the universe. The James Webb Telescope has been doing just that, and it's flipping our understanding of the cosmos on its head. In just 12 hours of observation, this marvel showed us things that left us staring wide-eyed and scratching our heads. Okay, let's imagine together how vast the universe actually is. Just let your imagination run wild and think as far as your mind can go, reaching the very edge of space. Now, let's find out just how much the James Webb Space Telescope can actually see out there. The actual reality. So hop on board our imaginary super-fast spaceship, and let's not waste any more time. Now we head to the edge of our solar system, passing planets like Mars, Jupiter, Saturn, Uranus, and Neptune. We've covered 100 astronomical units, and here we are at the heliosphere's boundary. Beyond this point, we enter interstellar space, where Voyager 1 and 2 have ventured. Now, we approach the Oort cloud, a wall of asteroids 200,000 astronomical units away from Earth. It's sparse, and we easily navigate through the asteroids, entering complete darkness. Zooming past stars and planets, we reach the edge of our galaxy within minutes. No more interstellar wind, just bright dots, other galaxies. Mapping our route, we realize our universe isn't infinite. It has a boundary 10 billion light-years away, and there might be other universes. The original supervoid, a billion light-years wide, could be evidence of a collision with another universe. But how do we get to these other universes? Black holes might be the key. They're mysterious, warping both space and time. Some scientists even propose the existence of white holes, the opposite of black holes. The idea is that these might lead to other universes. Remember the Little Bang in 2006? That unusual burst of energy could have been a baby white hole, destroyed almost immediately. Now, let's talk about the Andromeda Galaxy heading our way at 68 miles per second. Don't panic, it won't crash tomorrow. But when it does, things get interesting. We might witness stellar collisions, or perhaps our solar system gets thrown into dark space like a tennis ball released on a rope. Fast forward, the galaxies merge, and the black holes at their centers start a dance. They eventually merge into a supermassive black hole, releasing energy in an active galactic nucleus visible for millions of light-years. Then we've got the South Pole Wall, 500 million light-years away, containing a quadrillion stars. There's also the Hercules Corona Borealis Great Wall, a flat superstructure 10 billion light-years wide. And don't forget the huge, large quasar group, 4 billion light-years across and 6.1 billion times heavier than our Sun. And then there's the observable universe, over 500 billion galaxies each with billions of stars. But wait, there's a void called the aridness supervoid, or the cold spot, a billion light-years wide. Some think it's a result of a collision of universes, two bubbles touching and tearing material away. Now picture the universe as a giant bubble, and there might be infinite bubbles. Wormholes or portals inside black holes could be shortcuts between these universes. Imagine folding a piece of paper to connect 2 points without crossing the whole sheet. That's the idea. Speaking of black holes, falling into one could be survivable if it's supermassive. Gravity's effect increases gradually, avoiding the dreaded spaghettification. Who knows? Surviving a fall might land you in a different universe with different physics. Though for now, it's just a wild theory. So imagine you're out on a clear night, gazing up at the stars. It might seem like they're spread out evenly, right? Well, it turns out that's not the case at all. Those stars are actually part of something massive, a gigantic cosmic web connecting galaxies across the universe. Astronomers using the James Webb Space Telescope have just stumbled upon what could be the oldest strand of this cosmic web ever discovered. Now, let me break it down for you. In two papers published in the Astrophysical Journal Letters, scientists spill the beans on this incredible find. They use data from the James Webb Space Telescope to uncover a colossal tendril made up of 10 closely packed galaxies. It stretches over a mind-boggling 3 million light-years. Zhao Wei-Fan, an astronomer from the University of Arizona and part of the research team, couldn't contain his surprise, saying, "I was surprised by how long and how narrow this filament is. I expected to find something, but I didn't expect such a long, distinctly thin structure. It's like stumbling upon a hidden ancient treasure in the cosmic vault. This ancient filament of gas and stars dates back to a mere 830 million years after the Big Bang. That's practically the universe's baby years. And guess what's anchoring this colossal thread? A supermassive black hole, of course. This black hole is no ordinary one. It's a quasar, an extremely bright celestial object that acts like the anchor for this cosmic structure. The team behind this mind-blowing discovery is part of the ASPIRE project. What's ASPIRE? Well, it stands for a spectroscopic survey of biased halos in the reionization era. Fancy name, right? Their mission? To figure out how the earliest black holes influenced the evolution of galaxies. And guess what led them to this ancient filament? One of the 25 early universe quasars they had their eyes on. Fage Wang, an astrophysicist from the University of Arizona and the brain behind ASPIRE, is pretty excited. This is one of the earliest filamentary structures that people have ever found associated with a distant quasar, he exclaimed. It's like they stumbled upon a cosmic treasure map, revealing secrets of the universe's early days. Now, here's where it gets interesting. The researchers think that black holes played a crucial role in forming this cosmic web. Imagine black holes acting like magnets, drawing matter together with their gravity. But wait, they occasionally fling stuff far away with what they call cosmic winds. Gravity is the glue that keeps these strands of stars and dust connected, even as the cosmic winds try to pull them across the vastness of the universe. So, what's the future of this ancient filament? Well, the researchers have a pretty cool idea. They believe that over time, this cosmic thread will condense into a cluster of galaxies, kind of like the Coma cluster, which is about 330 million light-years away from us. It's like watching the universe evolve and create its own intricate masterpiece over millions of years. When the Webb telescope focused its mirrors on a patch of sky, it saw way more light and way more galaxies than expected. Not just any galaxies, but big, bright ones. Now, scientists are scratching their heads and coming up with different possibilities to explain this cosmic mystery. And let me tell you, these possibilities are like forks in the road, each leading to new questions and understandings. Option 1. Maybe stars and galaxies formed differently and more efficiently in the early universe. Imagine a dark room without many stars and galaxies, making it easier for them to form quickly. It's unexpected, but not a total rewrite of what we know. Option 2. What if the brightness is not from stars, but from supermassive black holes? Yep, you heard it right. Instead of a galaxy full of stars, we might be looking at galaxies lit up by these mysterious black holes. But if true, it challenges what we thought we knew about how many of these monsters existed in the early universe. Option 3. The most extreme possibility is that our understanding of the universe's recipe book, called cosmology, is incomplete. It's a bit radical, but it could shake up our understanding of everything. Option 4. And then there's the wildcard option. There might be some unknown component of the universe that we haven't even considered. Now, why does all of this matter? Well, it's about finding our place in the cosmos and understanding the story of how we got here. If we're missing something crucial in this story, it's like trying to solve a puzzle without all the pieces. And the more we dig into this mystery, the more questions pop up. Recent findings from the James Webb telescope have given us a reality check about the size of the universe. Like, we might have been way off. Scientists dropped a bombshell in a recent paper, claiming that the telescope caught glimpses of stuff just 120 million years after the Big Bang. If the Big Bang even happened. Moreover, it challenges the very foundation of the standard cosmological model. The universe might not be as old as we thought, and Einstein's idea of it being infinitely old? It turns out he missed the mark. Our intuition has been playing tricks on us, and we're starting to think we don't really have a clue about what's out there. The James Webb Telescope gazes into space, trying to see as far as possible, but it can only reach about 46.5 billion light-years away. We call that the Hubble radius, or Hubble sphere. And guess what? The most distant galaxy ever discovered by the telescope, the Macy's galaxy, lived just 450 million years after the Big Bang and is still within this Hubble sphere. Now, our universe is like a balloon that's constantly getting bigger. Not only is it expanding, but it's also accelerating in its expansion. Beyond the Hubble sphere, the universe is stretching out faster than the speed of light. But the Hubble sphere won't keep growing forever. There's a cosmic horizon limit, a fancy term for the observable universe. Imagine a gigantic imaginary shell around us, 93 light-years wide. That's our limit, the farthest we can see. Anything beyond that? Sorry, not visible. Yet, even if we had the craziest telescopes, the light from there just hasn't reached us yet. So how big is the entire universe outside our cosmic shell? Well, we don't know. There are competing theories, and math gives us a run for our money. Some say it could be infinite, while others throw around numbers like the universe being 10 circumflex 122 times larger than what we can see. But the distribution of matter in the universe and the even spread of temperature in the cosmic microwave background radiation suggests that our universe might be infinite. Yeah, you heard it right, infinite. Mind blown already? When we gaze into the vastness of space, we're not just looking at distant galaxies, we're sort of peering back in time. Those galaxies we see near the Hubble sphere, they're not snapshots of the present. They're like cosmic fossils, remnants of a bygone era billions of years ago. It's like having a time machine. But instead of traveling, we're just looking really, really far. Now, according to our cosmological model, about 14 billion years ago, the entire observable universe squished into a tiny point called the singularity. Well, that's the standard story if the universe is finite. But if it's infinite, which it kind of seems to be, then the Big Bang wasn't a localized event. It happened everywhere. Now, the first galaxies didn't pop up in a specific neighborhood of space. They were the universe's grand opening act, happening everywhere, even beyond what we can see. The big question, though, is what kicked it all off? What or who created everything out of nothing? Einstein was initially against the idea of a Big Bang. He liked the idea of a steady-state universe that had been chilling forever. But equations have a persuasive way of changing minds, and eventually, he hopped on the Big Bang bandwagon. However, some people, including our friendly scientist narrating this cosmic tale, think the singularity isn't the start, but more like a universal birth certificate. Now, just when we thought we had the universe's biography sorted, the James Webb Telescope came and blew our minds. It recently stumbled upon F200DB045, a galaxy that could rewrite cosmic history. This galaxy is so distant that, if confirmed, it would challenge our cozy 13.8 billion-year-old universe narrative. Now, Webb has found galaxies that shouldn't exist. I'm talking about massive galaxies appearing just a few million years after the Big Bang, a cosmic speedrun that defies our current understanding. Even more jaw-dropping, the telescope caught early black holes only 700 million years after the Big Bang. Black holes merging left and right possibly explain how these cosmic vacuum cleaners grew in their toddler years. Now, these discoveries are stirring up some cosmic chaos in the world of cosmology. The universe might be older than we thought, or it might not have had a beginning at all. Imagine if our universe is like that favorite storybook that never had a first page. It's always been there, just unfolding through different chapters. As we peer deeper into space, the idea of an infinite universe starts to make sense. If the universe seems infinite in size, why not infinite in age? Maybe the Big Bang was just a plot twist, not the opening scene. And it's a big but, we need more research. Does this eternal universe vibe jive with our current scientific groove? Can it explain the intricate dance of events during the Big Bang? There might be around 2 trillion galaxies out there, but astronomers are scratching their heads, wondering how much more of the universe is out there beyond what they can see. Virginia Trimble, an astronomer from the University of California, puts it like this: the universe has always been slightly larger than what we can see. It's like the universe is playing hide and seek, and we're desperately trying to figure out where it's hiding. John Mather, a Nobel Prize-winning cosmologist from NASA, breaks it down. We've already seen as far as you could possibly imagine. At the very edge, we catch a glimpse of the afterglow from the Big Bang. But, and it's a big but, this isn't the end of the line. The universe keeps going, and we might just never know how far. In their quest for answers, cosmologists have taken a leaf from the ancient Greek mathematician Eratosthenes' book. They're trying to figure out the shape of the universe to solve the mystery. Think of it like finding out if the universe is a giant saddle, a huge sphere, or a flat sheet. Now, the saddle-shaped idea doesn't have many fans, but a spherical universe feels cozy to us. Einstein dubbed this model a finite yet unbounded universe. But in the late 1980s, observatories studying cosmic microwave background radiation dropped a bombshell. It turns out that space has no curvature at all. It's as flat as a pancake, or as John Mather puts it, flat like an endless sheet of paper. So you could travel infinitely in any direction, and the universe would look pretty much the same, just galaxies on galaxies. Now, flat is fantastic for most astronomers. It fits with both what they observe and the theories they cook up. But unlike a spherical universe, a flat one could be infinite. Or maybe not. And there's no surefire way to tell the difference. Virginia Trimble sums it up nicely. What could you look for to see whether there's an infinite universe? Nobody quite knows. It's like trying to figure out if a pizza is infinite or if you'll eventually hit a crusty edge. Tough, right? So, you know how sometimes we wonder about the edge of the universe and what would happen if we tried to reach it? It's a mind-boggling concept, especially when you consider that the universe is supposedly infinite. But let's break it down a bit. Okay, so people often say the universe is everything, all of space and time. But is it really part of our universe if we can never interact with it? And what if, beyond the edge, our universe is totally different? These are the questions that keep scientists up at night. But what if the universe isn't perfectly flat? What if there's a curvature we haven't measured precisely enough? If there's positive curvature, the universe might be the surface of a hypersphere, a 3D surface of a 4D sphere. In that case, if we had a warp ship, we might eventually travel all the way around this curved hypersphere and end up where we started. But these ideas assume a simplistic application of Einstein's equations. General relativity is fantastic, but it's not the be-all and end-all. Some theories suggest our universe is just a slowly expanding bubble in an infinitely inflating multiverse. Bubble universes might be finite in size, with a true edge. What's on the other side? Do the laws of physics change? Maybe, maybe not. So, what's the plan? Well, astronomers are hoping for a lifeline from theory. They want a model that can indirectly prove whether the universe is infinite or not. It's like when physicists predicted the existence of particles like the Higgs boson before actually finding them. They had this hunch that the particles were real based on their model, and it turned out they were right. Virginia Trimble puts it in scientist speak. If you have a good description of everything you've observed so far and it predicts something is true, then you expect it is. It's the hope that a well-crafted theory will point us in the right direction, helping us unravel the cosmic mystery that's been boggling our minds since Galileo's first telescope pointed skyward. Now, here's the exciting part. You're not just a spectator. You can join the exploration. Share your thoughts on these cosmic revelations in the comments below. Do you think there's a hidden message in those distant lights? Or is the universe playing a game of hide and seek with us? If you're as fascinated by space as I am, hit that like button, subscribe, and ring the notification bell faster than the speed of light. We'll keep you updated on the latest discoveries and dive even deeper into the secrets of the cosmos. Until then, keep wondering, keep exploring, and who knows, you might just be the one to crack the code of the universe.